Hi, this is Mrs. Myers, and we are going to be learning lesson 7.5, proportions in triangles. We are going to learn two theorems. One is called the side splitter theorem, sometimes it's called the side splitting theorem, and the other one is called the triangle angle bisector theorem. In both cases, it will help you solve for missing sides in triangles. This is just a little joke here. I was looking for some side-splitting knock-knock jokes for kids, which is actually the title of a book that is out there. Side-splitting knock-knock jokes for kids, but this is what I found instead. I named my dog 5 Miles, so I can tell people I walk 5 miles every day. That's a good one. Okay. Why am I telling you a joke? Well, because I just think it's a little bit funny. The name of this theorem is called the side-splitting theorem, and so I say, well, if that joke didn't split your sides, this theorem will. I know I'm very corny, but anyway, the side-splitter theorem says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. Now, in other words, we're not talking about a median here. We're not saying that this is a midpoint. This is saying you can draw this parallel line anywhere. Okay, so it's not the same as a mid-segment. It's any parallel line drawn in anywhere in the triangle. Splits the sides proportionally as long as this is parallel. Well, that means that XR is to RQ as YS is to SQ. They are split proportionally. Now, not congruent. We're not talking about congruent. We're talking about proportional. So let's look at a few examples here. Find the value of the variable in each diagram. When we had problems like this before and we knew the numbers for all of them, remember we talked about this as similar triangles. This triangle is similar to this triangle. That is still true. And if you remember, we said think about this whole side as being proportional to this whole side of the little blue triangle. And this whole side as being proportional to this whole side of this triangle. So you could still do it that way. You could still write your proportion based on the similarity of the triangles. But this is meant to be a little bit of a shortcut, and it's meant to solve in situations like this where you have a lot of x's involved. Okay, so this theorem says 12 is to x plus 1 as 9 is to x. 12 is to x plus 1 as 9 is to x. You could think of it this way. When you have a side splitter situation where there's parallel line, it's like upper left is to lower left, as upper right is to lower right. There are other ways of setting up this proportion. You could say 12 is to 9 as x plus 1 is to x, but you need to have the right splitting situation. So let's look at how we would solve this. Cross multiply 12x equals, remember to use parentheses, 9x plus 1, and you're going to get 9x plus 9 equals 12x. Subtract 9x from both sides, and you get 9 equals 3x, and x equals 3. Over here, we have another example of two similar polygons, and we're talking about the splitting of the sides. In this case, upper left is to lower left, as upper right is to lower right. A is to A plus 4, as 12 is to 18. When we cross multiply, we're going to get 18A equals 12 times A plus 4 in parentheses. When we distribute, we get 12A plus 48 equals 18A. Subtract 12A from both sides, and 48 equals 6A, and A equals 8. So you're setting up your proportion almost like you could actually look at the triangle, and where your parallel line is, you could almost like extend that parallel line, and you have your two ratios. A is to A plus 4, 12 is to 8. And so you extend that parallel line and think of it as this over this equals that over that. Okay? Now, please take careful notice, because when you have a situation where this diagram looks just like these diagrams we had up here, this is a case where you cannot use side splitter. And it's because you don't have information about both split sides. If you think about extending that parallel line, like I said, we've got A over A plus 4, but we got nothing over here. When you got nothing over there, you can't use side splitter theorem. Here, they've given you information about the parallel sides, not about the split sides, or at least one split side. So in this case, you have to treat it just like we did with the similar triangles before. Think about this triangle here, the blue triangle, the little one on top, being similar to the green triangle here. So if we drew them separately, there's the green triangle, there's the blue triangle. This left-hand side of the blue triangle is A. The bottom of the blue triangle is 12. Well, when we look at the green triangle, if we're going to put something in a proportion with A, what corresponds with that whole left side of the blue triangle would have to be the whole left side of the green triangle. So that whole left side is A plus 4 plus A. In other words, 2A plus 4 is that whole side of the triangle, and 30 on the other side. So the proportion you would have to set up is A, left side is to left side, right? A is to 2A plus 4, as 12 is to 30. When you cross multiply, you get 30A equals 12 times 2A plus 4. We distribute, 24A plus 48 equals 30A. Subtract 24A from both sides. You're going to get 48 equals 6A, and A equals 8. Okay, so I'm going to let you try B on your own. So pause the video and try this one on your own. Remember, this triangle is similar to this triangle, and in this case you cannot use side splitter because we don't have information over here about the split side. So you have to use similar triangles here. So pause the video and turn it back on when you're all done. Okay, so you should have set up your proportion this way. 10 is to 10. Or 10 is to x plus 10, so left-hand side of the little triangle is to the whole left side of the big triangle, as x plus 2, the base, is to x plus 14. Now when you cross multiply, this is what you get, and you have to remember to distribute everything. Sometimes people say the FOIL method here. X times x is x squared. plus 2x plus 10x plus 20 equals 10x plus 140. A lot of distributing there. Make sure you're careful. This is going to be a factoring problem, so x squared plus 12x plus 20 equals 10x plus 140. When we have an x squared term and x terms, we have to get everything on one side and set it equal to 0 on the other side. So we're going to subtract 10x from both sides and get x squared plus 2x, and subtract 140 from both sides and get negative 120 equals 0. Now we have to factor this. I'm going to let you try to factor this on your own first. I'll pause the video again and then come back. Okay, so when you factor this, you should have gotten x minus 10, x plus 12, which when we multiply it out would get us x squared plus 2x minus 120 equals 0 here. And that's our factored form. X is equal to whatever makes this parenthesis equal 0, so x would be positive 10, or what x would make this parenthesis equal to 0, that would be negative 12. So these are your two answers, but remember, in geometry, this x corresponds with a length of a side. X is this length. Could x be a negative 12? No way. So we are actually ending up with just one answer. X is 10. Okay, next page. A corollary to the side-splitting theorem just says that if you have more than one parallel line, it splits all of these segments proportionally. This is to this, as this is to this, etc. So here's number 3. 3 campsites are shown in the diagram. What is the length of site A along the river? So we're talking about this shoreline right here. And we see that we have these pieces of information. So if we call this X, because that's the side we're trying to find, we can just set up proportions just like we would as if this was a triangle with side splitter. Again, you can think about extending your parallel line, kind of think of this as turned on its side now. Extending the parallel line, this over this equals this over that. So 9 is to 7.2 as x is to 8. 72 equals 7.2x, and x equals 10. So it would be 10 yards. Okay, there's another theorem that helps us find missing sides in triangles. This one is not really related to side splitter, but it helps us in the same way. If a ray bisects an angle, so in other words, if you have an angle bisector drawn in a triangle, and you can know that it's an angle bisector because the two angles here are marked congruent to each other. It's bisecting angle A. Okay, so if a ray or a segment bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. Blah, blah, blah. Sounds very confusing, right? But this is what I want you to think about. Look at these problems here. Okay, find the value of x. When you have this angle bisector, so you have to look for that congruent angle thing. In this case, what I want you to do is think about putting an equal sign right across that angle bisector. And then you have your two proportions, your two ratios. 10 is to 12 as 18 is to x. And then you're going to solve. Because the theorem says that this angle bisector divides the opposite side, so 10 and 18 are proportional to 12 and x, the other two sides of the triangle. But I like this trick. Put an equal sign across that angle bisector, and that gives you your proportion. So here, same thing. Put an equal sign across that angle bisector. Y is to 9.6. says 24 is to 16. And then you would solve from there. Okay, that is lesson 7.5. We have our theorems to help us find missing parts of triangles.